Okay, I passed this worksheet out. Did everybody get a copy? Oh, sorry, Elmer. I didn't get you one. Everybody else has one? All right. This is practice for the quiz that is tomorrow. I'm not going to go over these today, but there are matching like these on tomorrow's quiz. But on the back of the worksheet is a key with my written explanation of why they are what they are, okay? So this is for your benefit. I found an extra practice worksheet, made a key with explanation so that you could do this on your own. Yes? Everybody okay? All right. Also, worksheet 7, side B, has some more practice for the quiz. 7B we never went over. If you want to do 7B, you can take a picture of the answer key, check yourself as study practice tonight for tomorrow's quiz. All right. The other thing you should study is you should go back and make sure you know how to do everything from the first quiz in this chapter, 1.1 to 1.4. Because all of those, you have that quiz, okay? All of those concepts are still on this quiz. The new stuff, everybody, the new stuff that will be on this quiz will cover through 1.6. Transformations were 1.5, so that's what this worksheet is, right? Transformation stuff. You also have to be able to graph a piecewise function. I'm going to do an example or two in a minute. And all of section 1.6 is up for grabs as far as being on this quiz. That's all the stuff about composition of functions. Whether you put one function into the other, or you add them together, or you subtract them, or you multiply them or divide them. That's composition of functions. I don't have review on here of that. If you need me to do a couple examples, let me know. But please make sure you have done the assignment on page 61. It is not due in a homework check tomorrow. There is no homework check, okay? But if you haven't done page 61, then you've had no practice on the concepts that are on 1.6 that are on the quiz. Any questions about the general concepts that are going to be on the quiz? You can take pictures of any of the slides up here that you want. I am videoing this. All right, so those are the concepts that are on the quiz. From the last quiz, you have to know rate of change, symmetry, is it an even or odd function? Is it continuous? Where is the graph increasing, decreasing, concave up, concave down, all that kind of stuff. All right, now I have about 7 or 8 more slides here of review questions that I'm going to go through. So you can take pictures of any of these you want. We're going to go kind of quickly unless you stop me with a question. Because then in about 12 or 15 minutes, we're going to start talking about lesson 1.7 on inverses, okay? We are not going to get completely through the inverse lesson, but we'll be far enough in that you can start page 70 if you want. But it is not on the quiz. There's no inverses on the quiz, okay? All right, this is a quick review that you do not have of some of the parent function transformation things that could be on the quiz. The last 4 choices here, does this look like stuff you would all be comfortable saying you could pick out? Whether the graph went right, left, up, or down? Okay. Right, left, up, or down would be okay. The top 4 choices, though, are the icky ones that some of us have trouble with, yes? Besides vertical stretch, horizontal shrink, stretch, some of that stuff. What are these first 2, guys? The negative inside or outside is some kind of a reflection. Okay, which one is which? Putting a negative on the whole thing changes y values so it reflects over the x-axis. And that is the words you would need to use if it was an explain question Please say reflect over the x-axis. Don't say flip, okay? So I'm like, flip which way, do what? I would take that probably. All right, what about this one? I'd probably write reflect, but I wouldn't take a point. Inside is a reflection over the y-axis. Do you understand that some graphs you could reflect across the y-axis and absolutely nothing would change? If it had y-axis symmetry, yes? I could put this and the graph would look exactly the same. It's possible there's one on the quiz that, like, you go, wait, the graph didn't change. Okay, what does this absolute value on the whole thing mean? Right, the whole graph is going to be above the x-axis. Anything that was below gets flipped above. Because this means all the y's have become positive. This is the one that's way more complicated. You cut off the left side, and then you reflect the right side over so that it now has y-axis symmetry. All right, and then we talked about these. So can you tell what happened from this one to this one? It had -1, 0, and +3 as the intercepts, and now they're at -3, 0, and +1. So Miranda said reflected across the y. Everybody okay? Which is, all right, these are like matching, like it'll list these and it'll say choice A, B, C, D, E, F, G, H, and you just have to match them to the graph, okay? The same as on the worksheet I gave you today. This worksheet is harder than the ones on the quiz in terms of, these are pretty hard to tell, some of them, the stretch, but I did write clear explanations here, okay? All right, let's try this one. Can you tell what happened? It definitely looks funky. This is gone, and it now has y-axis symmetry. Now, that means this, but we had some discussion earlier today in one of the classes, but how can it all be negative? We don't know what the equation of the parent function was, but if you look at this idea, no matter what I put in for x, I get out, I'm sorry, whether I put a positive or negative x in, I get out the same y value. So when I put in a -1, I'm just going to say I'm at -10. If I put in a +1, I'm also at -10. Okay, so I'm putting in either a positive or negative x, and I get out the same y value. Now, it isn't all positive, but we don't know what the original function could have had a negative inside or something that made it all be negative, okay? The idea is just that whether I go left or right, I'm getting the same value out. All right, what about this crazy one? Oop, all this went up here and then like this, right? So what's that called? Okay, all the y's are positive. All right, can you tell what happened here? -1, 0, and 3 are now over at -4, -3, and 0. Shifted to the left. So which one is that? Okay. Real quick, does anybody know what this one would do? Yes, so this little bump right here, instead of going up to maybe 1 or 2, would go up twice as tall. This one that used to go down to -20 would go down to -40. But otherwise it would look pretty much the same. Okay? The intercepts wouldn't change where it's attached to the x-axis. If it had a different y-intercept, it would stretch. But all right. Also on the quiz is another question like this, like we had on the last quiz. I'm just going to make up some numbers and go through this really fast. Stop me if there's something you have trouble with. I'm going to say it crosses at x at -4, -1, and 3. You could write them as ordered pairs. I don't care. The y-intercept, I don't know. Can we just make a big dot and call it 20? Okay. The relative minimum point is somewhere over here. I'm just going to call it -3, -20. You would be doing this on your calculator, yes? And finding accurate values. But I'm not losing anybody yet. I'm just trying to do this quickly. I guess I'll be crazy and call that one 1.530. We okay? That would be the maximum. Okay. Increasing and decreasing is where we struggled a little bit. It asks specifically first for increasing. Increasing means as I go from left to right, where am I going up? So the portion of the graph we're talking about that was increasing was from here to here. As I trace the graph left to right, my finger was going up during that stretch. You give me x values or an x interval where that happened. So from -3 to +1.5. Okay? Decreasing is where it's going down as I go left to right, which was from the left-hand side until we hit -3. And then from 1.5 to the right. Again, it's x intervals where this is happening. Give me not y values, okay? End behavior. We good with end behavior? As x approaches -infinity means the left side, and we would say it's doing what? Positive infinity. As x approaches positive infinity means the right side, and on the right side this one is going down. Inflection point is where we think it changes from happy or concave up to sad or concave down. Somewhere in here, we're going to use the Hofbauer big dot theorem and call that -110. Okay? Because I'm just making something up. -110. Which side of that is it concave up or happy? This shape is the left side, which would be -infinity to -1, using the x value from whatever inflection point you picked. And then the right-hand side of that would be where it's sad or concave down, so from -1 to infinity. Any questions about the graphing stuff? All right. Symmetry is an issue that we struggled with on the last test because we want a graph. If we can see the graph, we're pretty good with symmetry. But if there's no graph and there's only equations, sometimes we struggle. The test that says if you can replace a positive x with a negative x or its opposite, and it does not change, that means it has y-axis symmetry. So if you had an equation like this, doesn't matter if I put in for x a +2 or a -2, I'm going to get out a 4 either way. Now the issue is, on the quiz tomorrow, it's a multiple choice question and it asks which one shows the correct symmetry and the correct test for the symmetry. So you would, if it showed this, you would have to also show this. It's multiple choice. You don't have to do anything. You just have to pick that they did the right thing. This is they've replaced the x with a negative x and showed that it stayed the same. All right. What is the test this test doing, guys? Replace y with negative y. Okay, this is x-axis symmetry, and it's actually not a function. But it might look like absolute value of y equals 2x plus 7. Because it doesn't matter what I put in for y, it's going to become the same number, right? Whether I put a positive or negative in there. The test would look like this. So this would just go back to what we started with. Okay? Or it could have had a y squared. Yes, doesn't matter. You squared, it's going to be the same. All right, and the final one, if you replace both x and y, so you had an equation like this. If you replaced them both, you would get negative y equals negative x cubed. Sorry, there was a negative out here too. So this would become positive. Oh, I'm making a mess of this. I'll explain this better. Okay, so if this is the original function and you replaced the x with a negative x, when you cubed it, you would get negative y equals negative. Here, this would be a negative x cubed, which would become what? Positive. And then if you divided both sides by negative 1, you'd have y equals negative x cubed again. You would just look for this test that replaced it, and you would say then it would have symmetry with the okay. I believe this was section 1.4. Not positive about that, the symmetry stuff, okay? So go back and look through your notes if you need to. Even and odd functions, this was really easy. Do you remember? Okay, so an example would be like x to the fourth minus 2x squared plus 7, because this has exponent 4, exponent 2, exponent 0. They're all even. But what did it mean to have that? Yes, this was y-axis symmetry, and odd was origin symmetry. And origin symmetry might have looked like this. There's some crazy business. Okay? Yes. For an odd one, if it was just a polynomial function, so it had 2 odd exponents or something, okay? Or even a plain x on the back because that's a power of 1, which is odd. All right, piecewise functions you have to be able to graph tomorrow. I'm going to go quickly, but tell me if you need me to go back over something, okay? This one is a line. Does that seem okay? And if you wanted to find some points on it, you could put in -3, -2, -1 to that function 3x plus 5. I believe this comes out -4, -1. This is a 1. I put that in and I get a 2, I think. Any of those going to be open circles? This one does not have an or equal to, so this is an open circle. The rest is solid and connected. So -3, -4. Is anybody checking that my points are right? -2, -1, -1, +2 is open. I think that's right. Okay. The second part of this function has a rule that is this. You do get to use your yellow parent function sheet tomorrow. It won't help you with much on the quiz, but if somebody needs a little help on this, the shape we're looking for is this. Okay? Just make sure you haven't written anything extra on that sheet. You also get to use your calculator tomorrow. No trouble. And you could type this in and find some ordered pairs if you want it on your calculator, right? All right, this one says from -1 on. Greater than -1 are values like 0, 1, 2, yes? If I put those into the square root, -1 plus 1 is 0, square root of 0 is 0. Nothing else comes out nice until I think you get to 3. That'd be square root of 4 is 2. These would be decimals. What do I have at -1? Solid or open circle here? So -1, 0 is right down here, and I have a solid circle. 0, 1 is a point. 3, 2 is the next nice one. And make sure you have a curve showing that it is the square root graph. We could do that one? There aren't any assigned that are really crazy, like reciprocal graphs where you only have 2 points or anything. Okay. There could be one like this. What's going on here? The other way that we talked about doing these at one point was, this is a parabola that's been shifted down 5. Everybody okay? Looks like this. You could graph it on your calculator, come up with a whole bunch of points. What am I going to do with this, though? I only need the pieces that go between -3, so it can't go beyond -3. Solid or dotted at -3? Solid, or open, I should say. And then at 2, I erase everything past 2. And at 2, it's open because it doesn't have the or equal to. We okay? All right. Now, this is what shape? A line that starts with values at 2. Okay, if I put in 2, I get out -1. Is that solid or dotted? Okay, but look what happens. When I go back here to -1, it's supposed to be solid. That's because this is a continuous graph. They overlap. Okay, there's not a gap. If you put in a 3, you get out a 0. You put in a 4, you get out a 1. So it's just doing this. So this one didn't have a discontinuity, which I'm not going to ask you about, but that's why that was filled in. All right, this is a question about discontinuous, and I think this is easier than the question we had on the last quiz, because the last one was a piecewise. The only time this graph is discontinuous is when it has asymptotes, or when it is undefined by the domain. If I factor this, what are the values that this cannot equal? The denominator says x cannot equal 3 or x cannot equal -2. Now, can x be 0? Yeah, because the top can be anything. The bottom is where the restrictions come in. So at 1, this is continuous. There's no undefined place there, so yes, it is continuous. At 3, is this continuous? No, because it's not in the domain. At 0, yes, it is continuous. You could test, remember, if you want, you could test values on either side and see that they exist. -2, no, because it's a restriction from the domain. Okay? Average rate of change, remember how to do that, or do you need me to go over it? 1, -5. I put in a 1, I get out 11. How'd I do? Put in a -5, I get out a -1. And then average rate of change is slope, right? Okay. I went really fast, but you're okay with that? Good, Tyson? Okay. Matching, like on the worksheet I gave you. Okay? That's also on there. Last thing, there could be something like this where I ask you for the words. So can you tell me what's going on here? How did the parent function f of x equals absolute value of x become this? Okay, so it's a horizontal shift right 1. If you just said right 1, I would be okay with that. Do this in order, guys. Remember, if I put a number in here, I would do this first, but the second thing I would do is this, which is actually what? And then I would vertically shift up 3. Do you understand why it's not the same as saying I'm going to shift right 1 and then up 3? Now it's up here. Because if I reflect that over the x, it's down here, right? Is that where it's supposed to be? This means it should be up 3, not down 3, right? So you have to say those in the right order. This would be a vertical stretch by a factor of 3. Okay, if there was a 3 out there. Okay, I'm done reviewing. Are we okay? Anybody have any pressing questions? Something I went over that was like, yes.
Okay. Does it matter what order? Like, say the first one also had a stretch of 3 and was reflecting over the x-axis. Which one would you want to say?
It doesn't matter. Yep. Good question. All right. These are notes on worksheet 12. We're going to talk about inverses for the other half of the period here. An inverse function is one that takes all of the ordered pairs in the original function and flip-flops them. So all the x's become y's and all the y's become x's. What does that mean about domain and range? Okay, so if we have an original function f of x and we have its inverse function, the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse, because you are flipping the x and y values. On this graph shown here, this is a function. It passes the vertical line test, yes?
Yeah.
Okay. I took all the ordered pairs and I flip-flopped them and I regraphed it, and it's now this. Is this a function? No, right? It is an inverse relation because we inverted all the ordered pairs, but it is not a function. In order for a function to have an inverse that is also a function, it has to be what's called 1-to-1, which means it has to pass the horizontal line test here. If a graph passes the vertical line test and the horizontal line test, meaning no horizontal line crosses it more than once, then it's called a 1-to-1 function, which means its inverse will also be a function. This talks about this graph right here, the green and the blue. It says, notice that these inverse relations are reflections of each other across the line y equals x. Oh, that's not good. No, don't want to do that. Please go away. All right. Do you see what I'm talking about, guys? This is the reflecting line here. If I folded, the green would match up to the blue. Okay. Remember, we're switching the x's and the y's. So does that kind of make sense that it would flip across the line y equals x? You switches the x and the y's. All right. There is also a note here about the notation. This notation does not mean this. Okay. This notation means the inverse of the function f. Don't ask me. I didn't get to make up the notations, okay? They didn't make me the math goddess. I have to just do what they tell me. All right. Not all functions have inverse functions. In order for it to have an inverse function, the original one must pass the horizontal line test, which makes it what's called a 1-to-1 function. This is at the top of your page, okay? Everybody awake? This is worksheet 12. You're looking at this? Some of you, I feel like you're not with me at all. Okay? There is a chapter test on Friday already, guys, that has this stuff on it. two relations are inverses if you switch the values to get from one to the other. This is the notation for inverse function. I'm going to write myself a little note here that the domain and range would also switch. The domain would become the range, and the range would become the domain. An inverse function passes the horizontal line test, then it is known as a one-to-one function, and it means the inverse is also a function. All right, so they just give us a few yes-no examples to break us into this very slowly. Here's a graph. They already graphed it for us. Does this pass the horizontal line test? No. That means the inverse is not a function. So we got to answer this. I'm not going to take time to type this in the calculator, but this is what this graph looks like. Would it pass the horizontal and vertical line test? Yes. So this graph has an inverse that is a function. It is actually its own inverse. I totally drew that graph wrong. It's in quadrant here and here. I did a negative, okay? But do you understand that if I try to flip that graph across that line, it's going to stay right where it is? This is its own inverse. Just saying. Okay, this graph is a parabola that's been shifted down 5. Is that going to have a inverse that's a function? Okay, the inverse is not a function because this is not one-to-one. It fails the horizontal line test. It's only asking you yes or no. I'm just trying to make sure you understand why. All right, this is a weird one. I typed it in my calculator and I got a graph that looked like this. What do you think? It's kind of hard to tell if it passes the vertical line test, but if you took and did trace out to the right, the y values don't stay the same at any point. They continue to get smaller and smaller and smaller. So it does pass the horizontal line test. So yes, the inverse would be a function. All right, those are the easy questions. They're going to be yes or no. Then we're going to talk, actually we already talked about this one, okay? This is just about the notation, is that little inverse and the domain and range switch. These are the steps to finding an inverse, and that's the rest of what we're going to get through today, is how to find an inverse function. You should have done this last year in Algebra 2, okay? First of all, you're going to decide if the inverse is a function. Then you're going to change any f of x's into y's, just so that we don't get confused between the x and the y. Then here's the part that's important. You're going to switch the x and y, and then you're going to solve for y. To use proper notation, you would then replace the y with this inverse notation. I'm not going to be picky. You can just leave it in terms of y, and I'm not going to count it wrong, okay? And then it says state any restrictions on the domain. All right, here we go. This one's done for you, so just watch my magic here. It said 1/4 x plus 3. I typed it in my calculator, graphed it. It's a oblique or slanted line, so therefore it passes the horizontal line test. Then I trade this out for a y. Then I magically change the x and the y because that's what an inverse does. The problem is I'm not going to accept that as an answer because you need to solve for the y. So I would subtract 3. Then I would multiply through by a 4 to get the y by itself. We good? Okay, this one is done for you right over here. At the end, they did go ahead and replace this with the inverse notation, and they distributed and got 4x minus 12. I would accept any variation of that, okay? You could distribute or not distribute, it's equivalent, so I don't care. And if you left it in terms of y instead of putting the inverse notation, I would take that as well. All right, here we go. Let's try this one. What are we going to do first? Is it going to pass the horizontal line test? Yeah, it's just a line, right? So right now this says y equals 2x minus 4. We're going to flip them. X equals 2y minus 4. Then what? X plus 4 equals 2y. We can divide the whole thing by 2. Or we could take half of each and do it that way. And if we wanted, we could replace the y with the inverse notation, and I don't really care either way. These are equivalent, so either one is fine. Okay, here we just divided both of them by 2 separately, which you could have also written x over 2 plus 2. All right, I'm not going to be picky as long as it's equivalent. All right, what about this one? The inverse is not a function because it's over here somewhere, isn't it?
Yeah.
But it's a parabola, fails the horizontal line test, so we just write inverse is not a function. By the way, there were no restrictions on the domain of this one because it didn't have any denominator or square roots anywhere. All right, still not too complicated. We're going to make this y, and then we're going to switch them. X equals 5 over y minus 2. Okay, can you tell me what you think we might need to do here? Okay, so if I multiply both sides by y minus 2, I'll get this. I could divide by x next, yep. And then add a 2. Okay. Yeah. This one, if I distributed, I would have gotten this. If I had added the 2x over to the other side, I would have had 5 plus 2x. And then I would have divided by x. Are those equivalent, guys? This one just has a common denominator. Otherwise, they're equivalent, okay? What is the restriction on x now? Originally, x had to be greater than 2, but on this one, x cannot equal 0. All right, number 7 is a cubic. The graph looks like this. Up at 4. Is it okay to do the inverse and you have a function? So this is a y. We're going to trade those. We will have x equals y cubed plus 4. Then what? Which the cube root function goes like this. Does that look like it would reflect across that line right there? Okay. There are no restrictions, even though there's a radical, because it's an odd power. You can put negative numbers into a cubic, right? So there are no restrictions there. I didn't write it in inverse notation, but you could. All right. We got 6 minutes left, and these are the tricky ones that are on Friday's quiz and on the final exam, okay? Sorry, it's pre-calc. I'm not going to ask just a simple little linear one. I know, don't hate. Okay, the trick to these, the reason these are tricky is because there's an x in 2 places. So when I switch this out for a y, and then I switch the x's and y's, this kind of becomes a nightmare because I'm trying to isolate y and I have it in 2 places. You have to multiply both sides by a y plus 4, or if it's easier for you, just think about cross multiplying, okay? You are going to want to distribute. Then what? If I'm trying to get y by itself, okay, guys, you want to isolate the y's on one side. So the way I have it written, I think it would be easier to subtract an xy over there. So I would have 4x equals y minus an xy. Does anybody see what we need to do then? We need to factor out the y. That's the trick, is you have to factor on all of these. Factor out the y. Sorry, I wrote that wrong. And somebody's going to factor it out wrong, guys. What happens when I take a y out over here? Be careful. I get 1 minus x. Don't forget that 1, right? Because it's got to be equivalent to distributing back through. Now, if I want the y by itself, I just have to do what? Divide both sides by 1 minus x. So it's 4x over 1 minus x. And x cannot be 1, right? Because that would make the denominator 0. All right, last one for the day. We're going to get through this number 9. I'm going to put it on a new slide so we have room. Is everybody okay, or do you need me to go back to that last slide? You just didn't understand. All right. This is what we're going to do. I'm going to write it over here in words, okay? We're going to switch the x and y. Then we're going to like cross multiply or whatever you want to call it. And then we're going to get all the y's on one side and everything that doesn't have a y on the other side so that we can factor and divide. So let's try it. This is going to say x equals y minus 1 over 2y plus 5. Please tell me I didn't lose anybody yet. All I did was switch the x and y's. Now what? If I cross multiply, what will I have? I'm going to go ahead and distribute. Then what? I need the y's on one side, everything else on the other side. So what would that say? You want to subtract this one over to the other side? It doesn't matter which way you go, guys. You'll get a different version, but it means the same thing. And then I'm going to add 1 over here. So I'll have 5x plus 1 equals y minus 2xy. Then what? Factored out the y so that we only have one y. We don't want a y in 2 places. And then I got to divide this guy over here. So I get 5x plus 1 over 1 minus 2x. Now, guys, you got to know everybody's answer is not going to look the same. Back here, if you had decided to switch the order around and move it, you know, a different way, you could have said 2xy minus y equals negative 1 minus 5x. Then when you took out your y, these are equivalent, okay? This is just the complete opposite signs of this one. I have to figure that out. You don't. You just do it and I'll decide if it's equivalent, okay? We will finish this lesson on Wednesday. Guys, I'm not here tomorrow. There will be a sub to give you the quiz, okay? Yes, because we all have to be at a training tomorrow, about 30 people in the building.